Hi, this is Elliot Haspel and welcome to another edition of Best Practices Weekly. Today we're going to be talking about patterns that promote algebraic reasoning skills, and this comes from an article in Teaching Children Mathematics in which a Ball State University professor is writing about this idea of how we can design problems that involve patterns that will really help elementary school students build those early algebraic skills. And the author talks about how there are two types of problems when it comes to early algebra, and she categorizes them as either stasis problems or change problems. And stasis problems are ones in which the variable can only be one value. There's no other option. And the example problem that she gives is one in which you're talking about a person who maybe went to the movie with her friends, and the problem will tell the students how much the person had, how much they spent on the popcorn, how much they spent on the sodas for their friends, and if that's all the case, then how much must one movie ticket have cost. And in that problem, the x, the variable, could only be one value. There's only one thing that would allow you to complete the problem successfully, and so that's why it's called a stasis problem, because it can only be one thing. It stays the same always. The alternative to that is a change problem, and a change problem is one in which you're actually leading the students to see that variables are changing depending on the situation. And I'll go into more detail about that in a moment, but the example problem that the author gives here is saying that there's this person and they open a savings account and they're given $100 by their parents to start it, and she plans to put in $7 every week. And then you start asking a series of scaffolded questions to bring the students to understand that actually there's a pattern here, there's a rule, and the variable is changing in predictable ways. Questions like, how much will she have in there after the first week? How much will she have in there after the third week? How about after the fifth week? And then you can start to generalize it out. How much will she have after 20 weeks? So they're not counting anymore. Write an equation to show how much money she'll have in the account at any given time. And then you can get to a word problem. She wants to buy, the TV show on DVDs, and DVDs cost this much money. How much does she have to save up in order to get that kind of money? And so you've now, instead of just asking that to begin with, you've actually brought them through a changing set of variables to understand that the variable in one particular place is only one application of a rule. It's not that it's the only answer it could ever be, it's the only answer to that particular problem. And so a couple of characteristics of change problems are that the variable changes methodically with each step. It doesn't have to be a question around money. Other examples the author gives is you could talk about a geometric shape, word problems about cubes that are painted in certain ways, and thinking about how many cubes on a face would be painted depending on how big the cube is. There are any number of these that I imagine one can find on the internet, problems that would help you develop, that would be methodological in that kind of a way. Then the rule can be applied at any step. So in the problem about the money and the savings account, at any point when you have the equation, it lets you find the answer. And lastly, you should be able to generalize from the specific to the abstract. So that means that change problems help students go from very concrete ideas, how much money is in the account on week 2, or how many cubes are painted if the entire cube is one particular height, and then slowly building them out to the abstract, to the rule, helping them guide themselves to see that actually there's an equation here. The variable actually will matter depending on what the other pieces of information are. And so what the author talks about is that if we move towards change problems when we're talking about patterns, then we're actually going to really help students build their algebraic thinking, because ultimately algebra is about patterns. And whereas the stasis problems make algebra seem like this very sort of out of left field thing, that actually helping students see that algebra is simply a pattern that's changing predictably, we can really start to build even young students' skills using patterns in how they're thinking algebraically. Thanks for watching, and happy teaching!